I'd love to jump right in. You're someone who has researched supplements, longevity, micronutrients, and nutrients for a long time. And I got to ask, do you think that people can solve for optimizing longevity with diet and lifestyle habits alone, or do you think taking supplements is necessary?
I think diet and lifestyle are the major levers in aging and longevity, but supplementation can definitely fill in the gaps and help us along the way. So, a proper diet, being active, exercising regularly, getting good sleep, reducing your day to day psychological stress, having social connection. All of these things are extremely important. Trying to be in a clean environment, clean water, clean air, limiting your exposure to pollutants or other things that can damage your system. But everyone is exposed to some forms of outside intruders to the body. Whether it's pollution or whether it's day to day stress. These are things that everyone encounters. And supplementation does have a place in terms of if you certainly have deficiencies in certain areas, or especially as people age, certain endogenous systems in your body break down. And there's various supplements that can support and bolster those built-in systems to allow you to function better for longer.
We're going to get into supplementation in a minute, but I wanted to double click on that because I think one of the things that a lot of people struggle with is there's so many options and so many things that people are telling them to do when it comes to longevity, health, throw biohacking in there. What have you found for yourself to be like the most important things for yourself? Like, is it nutrition? Is it how much you sleep? Is it managing stress? Like if you were starting out fresh, knowing what you know now, what are the few you would really focus on mastering first?
The big three would be just a healthy diet, and then being active on a regular basis and getting good sleep. And they all go hand in hand. If you're getting good sleep, you'll make better decisions. You'll feel like you have more energy to exercise. Your body will recover and repair in better ways. And if you fuel yourself properly with a healthy diet, with the proper nutrition, then you're powered to get through the day, feel good, not have blood sugar spikes, et cetera. So I think those are the big three. And then, of course, everything else related to managing your stress and optimizing your social connections. There's a lot of other things that are really important as well. And then on top of that, then I think finding the right supplements amidst all the noise out there can help you as well.
Yeah, let's talk about this. You spent decades researching this, and as a personal trainer, I've seen clients over the years try to out supplement like a bad lifestyle or shortcut into longevity, right? Where they don't exercise as much. Maybe they go to the gym once or twice a week. Maybe they get a little bit of cardio in. Maybe they eat some protein, but not a lot. But yet they see all these supplements and they listen to a podcast like this, or they'll find others and like, you know what? I heard about this supplement on a podcast. It says it can help me live longer, it can help with aging. Let's just take that and see if it fixes things. And it's just not that simple. And there's a lot of supplements, just frankly, that just don't meet the expectations of what they say. What is your overall view of the longevity supplement space as you see it, as someone, this is your business, you're in it? What is your overall perspective?
I think there's a lot of noise. There's a lot of hype. There's a lot of claims. There's a lot of people marketing for various things. There's certain things that are backed by big names, big companies. And certain things get more weight based on how much money is behind them, what the resources are to promote them. And so you may have certain things that become really popular, become fads, but may or may not have a whole lot of science behind them. Or they may have some intriguing science in preliminary research studies that doesn't necessarily translate into human or clinical applications. So I think it's really important to try to parse through all the noise and dig into the science and see what's real, and also to look for independent, robust studies. And so just as an example, the National Institutes of Health, specifically the National Institute on Aging, which is one of the institutes at the NIH, has a program called the Interventions Testing Program. And this is a highly rigorous, highly robust program that has been ongoing for the last 20 years. It's conducted at 3 different research institutions: the University of Michigan, the University of Texas, and also a research institution in Maine. And there are investigators at each of these institutions that have specially bred mice that are well suited to studying longevity as compared to your typical inbred laboratory mice that are used for a lot of basic research. And they have thousands of mice each year that are bred for this program. They are housed and fed and held under the exact same conditions. And the researchers will select about 5 longevity interventions each year to see if they can have an impact on the lifespan of these mice. And so there's a new cohort each year that's tested. And this is highly rigorous because it's conducted in triplicate at 3 different sites in parallel with thousands of mice. And so each test agent gets hundreds of mice to examine, and then you have a control as well. And this is the program that put rapamycin on the map as a longevity agent many years ago, which is a drug that was repurposed, from like organ transplantation use, and it turns out that it impacts some important pathways related to aging. And it's been shown in this program, the ITP, the Interventions Testing Program, to extend lifespan. And so the molecule that we work with, which is called astaxanthin, which we can talk more about a little bit later, but it was selected for this program based on research that we had collaborated on with the University of Hawaii, showing that astaxanthin had impacted an important anti-aging or longevity gene called FOXO3, and it activated in the heart tissue of mice in this research study, which built on other preliminary research showing that astaxanthin extended lifespan. So we supplied astaxanthin to the ITP program back in 2019 when the cohort was initiated. And the ITP followed the mice for several years, through the end of life, and compared how long the mice lived that were taking astaxanthin every day compared to the controls that didn't, and compared to the other agents that were also being tested. And it turns out that astaxanthin extended the lifespan of the male mice by 12% with very high statistical significance. And 12% is a meaningful amount, which if you were to translate or extrapolate to humans might be on the order of a decade. So an extra decade of life is a meaningful amount. And to put this into perspective, in the 20-year history of the ITP, there's only been a handful of agents that have extended lifespan more than 10%. And of those agents that have extended lifespan more than 10%, astaxanthin is the only one that has an extraordinarily excellent safety profile that allows for everyday use without side effects and something that can be tolerated every day, unlike, say, rapamycin, which has tolerability issues, and that's broadly accessible as a supplement. And so things that have worked in ITP are things like rapamycin, which are repurposed drugs and may or may not be things you would actually want to take every day. And so this is a program that has also tested things like resveratrol or curcumin or omega-3s or green tea and other longevity agents like some NAD precursors. And all those other agents did not show efficacy in this program. And it doesn't mean that they don't have utility in terms of health or even potentially in terms of longevity. But looking at actual lifespan in a mammalian model, ideally you'd look at humans, but that would take decades to actually follow someone from being younger age or middle age or even older age and follow them for many years or decades. And so you have to pick a mammalian model that actually is something within the realm of feasible research. And so these mice are the best, that we have available to feasibly look at lifespan. And so to show that astaxanthin extended lifespan with very high statistical significance in this model is something that allows you to cut through that noise and see, okay, here is an independent research program. You can't pay your way into it. You have to be selected by the program based on all the promising preliminary research. And then you actually have to show that your molecule works in that program. And then the study was published a couple years ago in late 2023. And so that's something that on top of the 4,000 peer-reviewed papers that support astaxanthin's utility, as well as around 100 human clinical studies, this really helps to validate its role in longevity and separate it from virtually all the other longevity agents that have so much hype around them. So that's one way that you can try to figure out, okay, what's real, what's not. Look at the science, look at independent, validated studies, and see if this is something that really holds weight in terms of and backs up the claims that are made.
We're definitely going to dive more into astaxanthin in a little bit, but first, I know that people are so busy, and it can be tough for them to like research supplements on their own, or to like look at reviews of studies, or to go to different sites and check things out. Like, what do you think the average person could do just to see if a supplement is actually backed by science?
I think it's a combination of you can look to trusted people, voices in the space, such as yourself and others that have. I think podcasts are a great way because it's very different to have a 30-second ad or some digital ad on social media or on Google that pops up, and you don't really have enough space there to really go through the science. A podcast allows people to have a conversation, to actually talk about the science, to reference studies that can be verified. And so I think that's a great first step for a lot of people to maybe hear about compounds that they haven't heard about, or maybe to learn more about those that they've heard about but don't really know much about. And I think it's a great forum, to learn. And then from there, you can look to various, you can go to PubMed, which is the national, kind of archive of peer-reviewed scientific literature, to search and pull up some studies maybe that are talked about. Or ideally, that certain studies will be referenced, by those that are discussing it or promoting it, and then one can go and look and see, okay, yeah, this is an actual study that was published, and you can read through the abstract, get a sense of it. And for those that really want to dig deeper, they can actually look into the details of the papers. But ultimately, you're either looking into the science yourself, but if you don't have a scientific background, you don't really know what you're looking at, what's real. Is this representative of all the literature, or is this one particular study that might be an outlier that gets marketing hype around it, but actually is not representative of the overall totality of the evidence. So I think it's a combination of listening to trusted voices, of course, speaking with your healthcare professionals, talking to them about things that you may have heard about. And so I think between your, healthcare professionals, trusted voices, in the space on podcasts in particular, and then looking at, sites like PubMed, and other referenced research, by whether it's individuals or companies discussing these molecules, that's a good way to go about it. And then, of course, you have the community. So you can look at, friends, family, you can look at the reviews for products, and hopefully, get through which reviews are promoted reviews versus real, authentic reviews, and get a sense of what seems to be helping people. Because you can look at, in the case of longevity, there's how long you live, and ultimately, you won't know that for a long time, hopefully. But you can also look at health span related metrics, and so how are your day-to-day energy levels, your joint and muscle function, your cognition, and hopefully you're staying, at as high of a level as possible, without that decline. Because you don't want to be declining with age and living your final years, in a, suboptimal state. And so really, if you can see those benefits in your day-to-day, cognition and, bodily functions in terms of, joint and muscle function, your recovery, your endurance, all of these things, that's another way that you can assess, as you potentially start utilizing, diet, lifestyle interventions, or supplementation as needed.
And it's a huge adversity for people, I think, because people are trying to navigate this space. They're seeing advertisements for supplements. They're wasting a lot of money because supplements can be expensive, as you and I both know. I mean, the right ones are certainly worth it. And that said, they also end up wasting so much time, taking the wrong things, and it prevents them from doing the things that actually work. And it becomes this rat race, right? Speaking of rats, you mentioned mice, and I know that astaxanthin has like human trials as well, but I know that sometimes people can look at trials in mice and they're not the same as humans. Talk about your perspective on that, and why or why not should people take mice studies seriously?
Yeah. So Ideally, you could just research everything in humans, and just from a ethical, moral standpoint, and just from it being the most relevant to our actual health. But it's not feasible to do everything in humans, whether it's lifespan studies, or even studies looking at various health applications, because conducting human clinical trials is very timely, costly, and it's just not feasible to advance the research for most people, for most companies in this space. Human clinical trials are what are used on large scale to approve drugs for specific indications, and are also done with supplements, in studies that typically involve tens or potentially hundreds of people, but typically, 10, 20, 50, types of people are used in these studies, and it gives you a good indication of what's happening in humans, but it's still not going to rival the thousands of subjects that are used in trials for drug approval purposes. And these are trials that can cost tens, if not hundreds of millions of dollars. And so it just creates this real barrier to advancing the science. And so with animal studies, it allows a lot more research to be done, and then allows you to pinpoint various areas that then you take forward and invest in humans. But otherwise, you wouldn't really have as good of a starting point in terms of what type of disease area or mechanism you're looking to impact, or potential dosing. And so with animal studies, there can be a lot of studies in animals that can give you comfort around application for a various area of health or longevity. But you also want to look at how does that translate to humans. And so you can look at other agents that have been tested, and if they worked in this model, did they work in humans, for example. And so there's a lot of research that goes into not just, can you impact heart health or brain health or joint health in some animal species in a non-clinical study, but also is that relevant to humans? So it's a bit of both, but you shouldn't only rely on the animal studies. It should give you an informed basis for what research is done in humans, and then ultimately, you want to rely ideally on human studies to know if it works. But even with that, after drugs are approved, say for example, with very rigorous human clinical studies, a lot of doctors still say, well, I don't believe it until I see it in my practice working with my patients, with my real world patients, because a lot of times clinical studies, you have specific inclusion and exclusion criteria for the exact type of patient or subject you're going to include in your study to be administered the agent, and that may or may not be representative of what is your exact situation, or the situation that a clinician or a physician may see in day-to-day practice. So there is all of that that has to be kind of adapted to the real world. But it's kind of a numbers game where you just have a lot more research in animals, so it gives you a lot more of an indication of the potential areas that could be impacted, and then from there you kind of work your way up into larger order mammals, and ultimately into humans.
So let's talk about astaxanthin. Explain it to me in a way that's so simple I could easily explain it to my wife when I'm done this interview.
Yeah. So astaxanthin is a natural molecule. It is present in the marine environment in particular, and it is a very potent antioxidant and anti-inflammatory, and has showed utility, throughout the animal kingdom. And so, interestingly, astaxanthin is what makes many of the marine creatures pink or red. So it's what makes salmon pink or red, crab, lobster, shrimp. These are all red or pink or orange because of the astaxanthin that they get in their diet. So it's this natural pigment that imparts color, and it actually goes back to the early evolution of plants, and it's part of the carotenoid family, which notable relatives include, say, beta carotene, which most people have heard of, or lutein and zeaxanthin, which people may have heard of. They're all part of the same family of carotenoids that co-evolved with photosynthesis to protect plants and algae from the impact of the UV light from the sun. And so it helps them deal with the oxidative stress, that can be generated from the UV light. And it's something that was then conserved through evolution and up the food chain. And so it's part of the diet of these crustaceans and of salmon and even flamingos that consume crustaceans. That's how they become pink. Without it, they would be white or gray. So it's this natural pigment that's highly prevalent in the natural environment that we've all consumed. Eating salmon or lobster or shrimp, but most people have never even heard about it and would have trouble pronouncing it. But it's this real interesting kind of miracle of nature type of molecule that has all these interesting properties in terms of cellular health and impacts on oxidative stress, inflammation, overall health and longevity. That's been really exciting to see the research unfold over the last 25 years.
So we're going to talk about the longevity benefits in a moment, but for somebody who maybe is in their 20s or in their 30s, maybe even in their 40s, like somebody who maybe they're not like getting to that point where they're thinking about like really focusing on aging. What are some of the benefits that people should consider from that?
Well, there's several. First of all, it's never too early to think about aging, because you don't want to wait until you decline to then try to fix things or counteract things. It's better to stay healthy, stay active, and so. If you think about that curve of your health span declining over time, you'd like to kind of keep it as high as possible. So I think it's an important thing to think about everything from your diet and your lifestyle at an early age, and really stay on top of that, so that when you're in your 40s and 50s and 60s and onward, that you can remain active and enjoy life and be productive and be there for your family and friends and yourself and all of that. But also on top of that, in terms of day to day, what does that mean in terms of the health benefits that one may realize? It can impact your energy levels. So astaxanthin gets to the mitochondria, which are the energy plants in your cells, and helps them function better and more efficiently produce energy, and also produce more mitochondria and clean up old mitochondria, things like that. So you're going to have potentially better energy levels, not like an energy drink, but more like sustained energy on a daily basis. It can also help with endurance and recovery. For instance, there was a study in young cyclists that were, I believe, early 20s, that competitive cyclists, and they looked at the time to exhaustion, where they were holding a pretty high level of output of a VO2 max of like 75%. And in the control group that didn't have astaxanthin, it took them about an hour and 12 minutes before they were exhausted and couldn't keep going. But in the astaxanthin dose group, they were able to go to like an hour and 25 minutes. So like a 13-minute improvement, which is like more than 10% improvement. And so that's a real world application in terms of endurance. And so you see a lot of athletes, like Ironman triathletes, for example, that have used astaxanthin as part of their regimen for many years because of those benefits. It also helps with recovery for muscles, with all the intense use and abuse that exercise takes on your muscles and on your joints. Inflammation, oxidative stress can impact, the lubrication of your joints and the cartilage, and can break down the cartilage over time. For example, astaxanthin can help to mitigate that, so it can help with your joint mobility and comfort. It can also impact your cognitive function. There have been human studies showing impacts on information processing, memory, recall, all of these things. So there could be improvements in terms of your day-to-day cognition. There's also benefits related to skin health. Reduce fine lines and wrinkles, and better moisture content and elasticity. So it's not necessarily something that a person in their 20s is highly concerned about, but I think that the current generation is much more interested in skin health and overall health, and so one could hopefully maintain healthy skin as they're aging. It helps to fight off, just like in the case of the algae that produce astaxanthin to fight off the UV light from the sun, the damages from that. Astaxanthin can do the same for us, so it can help to mitigate the damage. The sunlight, the UV light can damage the DNA in our skin cells and break them down over time. And astaxanthin can be on board internally to help you deal with day-to-day sun exposure, and not as a substitution for sunscreen, but as a supplement to that. And then in addition, there are a variety of other areas in terms of overall health, like your cardiovascular health, your metabolic health, where you may not feel that necessarily, like your cholesterol levels or your blood pressure. But these are things that if you get routine blood work done, which is less frequent with those that are younger, but as people age, they tend to get blood work done more often. And there's a lot of great services now that make getting your blood work done more easily, in terms of whether it's at-home blood draws or going into labs that are nearby to your house. And then there's various platforms that analyze those blood tests and give you a review of your biomarkers to see what things are looking good and what things are not. And those are things that astaxanthin can help to impact. So you can measure those as well on a regular basis to make sure that your heart is functioning properly, your metabolism is on point, et cetera. So there's a variety of things that people at all ages, can look to, and hopefully, benefit their health and their longevity, kind of at all ages.
Did you just describe a magic pill? No, I'm kidding.
Yeah. No, that's the thing. I mean, so it does sound like a little bit like that, or like snake oil, and that's kind of one of the knocks. But when you think of all these things as different things, it sounds like, oh, how could it do all these, different things? How could it have all these different benefits? But when you think about what's happening at the cellular level throughout your body, there's a fundamental relationship between all of this. All of your cells are comprised of the same things, of lipids and proteins and DNA, and these cells have membranes that are prone to damage, and proteins that are prone to damage, and your DNA as well, and so just the normal function of your cells, whether those cells are in your brain or in your heart or in your joints or in your liver, are all susceptible to damage from oxidative stress and inflammation, and can manifest themselves into various, what appear to be different, disorders, but are related, or basically kind of the same thing happening, at the mechanistic, cellular, molecular level. And with astaxanthin, when you ingest it orally, whether you're eating it in your diet or supplementing your diet with it, it naturally, gets distributed throughout your body. It gets packaged into like LDL and HDL, and hitches a ride on them throughout the body and gets transported to all your tissues. And so you have astaxanthin localizing throughout your body. It even crosses the blood-brain barrier. So you get it into your brain, you get it into your heart, you get into your liver, your muscles, et cetera. And so when it's loaded into all these key organs and tissues, and then helps protect the cells that comprise those tissues from oxidative damage and inflammatory damage, that's how you can have an impact on all these different areas. And so it's not a magic pill that is meant to counteract a poor diet or poor lifestyle, but it can bolster all of that, and help you in all these different areas.
So how come we haven't heard about it more? Because I mean, as I've looked into it, I'm like, oh, this is super powerful. There's a lot of research behind it. You're very trustworthy, but I hadn't really heard of it, in itself before, you and I started talking, before Max texted me and was like, hey, I really think you should have this guy on. What he's doing is awesome. Like, why has other supplements gotten more attention versus what you're talking about?
Yeah, I think it's just, it's not hyped up or something sexy like some other new treatment, or for instance, there are other agents where you may have a group of Nobel laureates that kind of support a particular agent or research, and then there becomes a lot of press and hype around that. And for instance, that has happened in the NAD related space. Or going back to resveratrol, back in the, like 20 years ago or so, there was some research with resveratrol that became really, popular and led to some development on the pharmaceutical side, and then a lot of hype on the nutraceutical or dietary supplement side as well. And so when you get certain high-profile researchers that advance the science in interesting ways, that sometimes gets a lot of press and a lot of commercial backing. So we've seen that with various NAD related products and resveratrol related products. The whole, red wine is good for you, was all tied into that as well. And then in other cases, there's things like, say, like omega-3s, fish oils, where just the research on those, started expanding, years before astaxanthin. And so, for instance, in the late 90s, when I was first introduced to astaxanthin, there were no human clinical studies, and there were less than 200 peer-reviewed papers. And at that time, there was already a lot more research done with omega-3s, just based on, how science works, and researchers happen to take an interest in one molecule or another, and then more science sparks more science, and the research grows from there. And so in the last 25 plus years, it went from, with astaxanthin, less than 200 peer-reviewed papers to now more than 4,000 peer-reviewed papers, and no human clinical studies to around 100 human clinical studies. And so it takes time for the research to evolve around something. But then even in that case, you would think with 4,000 peer-reviewed papers and 100 human clinical studies, you would know more about it, or have heard more about it. But again, if you don't have massive commercial backing, or a big pharma company developing a molecule around it, or a celebrity tied to a particular brand, or a major consumer health company pushing a compound, then you don't necessarily get a lot of awareness around a molecule. And so that's what we've been trying to do, is like, let's get the word out. Let's have conversations on podcasts about astaxanthin, and try to create awareness. Because if people take a look, the science is very robust, and it's just something that hasn't enjoyed the spotlight like some other agents have, that may have utility but don't necessarily have the same level of evidence that astaxanthin does. The name itself doesn't help either. It is hard to pronounce astaxanthin, and when you look at it on paper, it can be a mouthful to try to say. But in any case, I do think that with these types of efforts, there will be more people that hear about it.
Yeah, I definitely had to practice before we recorded, because I mean, I've obviously taken the supplement and seen it, but I haven't pronounced it a whole bunch, so I was like, I need to make sure that I can say this like 10 times fast or whatever. One of the other things that I guess adversities people have with supplements is like, well, you can just get it in your diet, and you look at flamingos, you look at crustaceans, you look at salmon, they get astaxanthin from their diet. Why can't humans kind of do the same thing?
Well, you can. And so, for instance, a nice fillet of salmon may have anywhere from a few milligrams of astaxanthin up to 8 or 10 milligrams in like a bright red sockeye salmon. But if you have, say, a farm-raised Atlantic salmon, which is not dyed pink, by the way, a lot of people think, incorrectly or hear that farm-raised salmon are dyed pink or red. They're actually fed astaxanthin in their diet. They just maybe not have as much astaxanthin as a deep red sockeye salmon, for example, but they still have astaxanthin, and it helps give them their coloring and helps to support their health and vitality. Which so otherwise the farm-raised salmon would be smaller, weaker, more prone to infection, and gray, rather than pink or red. But in any case, the farm-raised salmon don't necessarily have a whole lot of astaxanthin, that would be as much as one may want to have. But some people may prefer the taste of farm-raised versus wild, and it all depends. And there's pros and cons for both of those. But in any case, you're getting 2, 5, 10 milligrams of astaxanthin, and so if you can do that every day, then that's pretty good. But most people don't eat a big fillet of sockeye salmon every single day, to get that much astaxanthin on board. And for instance, when we looked at the blood levels of astaxanthin that were achieved in that ITP study, looking at lifespan in the mice, and then look at what doses in humans have been used to get the same type of blood levels of astaxanthin, to look at how much astaxanthin actually got absorbed into your body and was useful for, to support your overall longevity. That translates, based on our research in human clinical studies, to probably something in the range of 12 to 24 milligrams of astaxanthin. So if you were to eat a big, nice, piece of sockeye salmon every single day, that would probably be on the lower end of getting you into the range of what the blood levels were that we saw the longevity, life extension results in the mice. And then, for instance, we've also conducted a clinical study looking at cardiovascular health biomarkers, LDL cholesterol, triglycerides, blood pressure, et cetera. And we found that actually we had a high dose of 96 milligrams, which is a much higher dose than most people would take. And we actually saw a great efficacy there in terms of statistically significant reductions in LDL cholesterol, and importantly, oxidized LDL. Because when the LDL becomes oxidized, that's extremely bad for you, and really worsens your heart health. We saw reductions in cholesterol or in blood pressure. And then also in a subgroup of people that actually had diabetes in that study, we saw reductions in their triglycerides and in their hs-CRP, which is a measure of inflammation. And so that was 96 milligrams. We also had a 24 milligram dose group, which had benefits, but not near what we saw in the 96 milligram group. And then we had a placebo group. So it was a randomized placebo-controlled trial. And of course, there was no benefits there, or things even potentially got worse. And these were real-world cardiovascular patients that were on statins and blood pressure meds and were not in good shape and didn't have great lifestyles. And this was seeing if we could give them astaxanthin and have an impact. And so that's an idea of looking at 24 to 96 milligrams. And in practice, most people take anywhere from 12 to 24 to 48 milligrams. So 1 or 2 or 4 capsules a day of 12 milligram astaxanthin capsules. And so to compare that to dietary intake, again, it's possible. You just have to eat a lot of salmon. And if you're eating, crustaceans, you're getting much less. Krill oil, has astaxanthin, but it's microgram amounts, not even milligram amounts, if you look at the label on krill oil supplements. So it's something where I think, eating salmon on a regular basis has a lot of health benefits from the astaxanthin, from the omega-3s, et cetera. But it's just hard to get the levels of astaxanthin that truly appear to be tied to the most health and longevity benefits.
And so are you 100%, I guess, convinced based on your own research and the research that's been done clinically that that astaxanthin does cross over the blood-brain barrier and it can actually gets absorbed in the way that's efficient? Because I know sometimes supplements, they don't in the same way.
Yeah, so we've done human clinical studies that have confirmed that astaxanthin gets into the bloodstream, and we of course can't sample brain tissue. I mean, I guess you could do a brain biopsy, but no one has volunteered to do that. And so, but and here's another example where in the case of animal studies, you can look at the tissues, and so we have worked with contract research organizations and, have had in-house scientists that developed analytical methods to take the tissue, from research animals and confirm that you have astaxanthin in the actual tissues. So the heart, the liver, the brain. And so we have done that ourselves in our own research, but then others, because this is a natural molecule and it's something that's studied internationally, a lot in Asia, but also in Europe and throughout the US and the rest of the world. There have been other studies as well that have also confirmed that it's been found in the brain tissue, which is corroborated by the impacts on brain health in a variety of areas, both human and animal. So we have seen that, and then certainly in the case of humans, we have definitely confirmed the bioavailability. And like you said, with supplements, you don't always know if you're absorbing them. Something may have some cool science behind it, especially in animals, but then when it comes to humans, it's hard to actually absorb it. And in the case of astaxanthin and carotenoids, they are poorly absorbed in rodents, and so you have to actually give them quite a bit more. If you actually look at the dosages tested, one may say, "Oh, wow, that's." If you just translate that based on the body weight of a mouse versus a human, you're like, "Oh, I'd have to take so much of this to have the same effect." But because they don't absorb it as well as we do, fortunately, we absorb carotenoids and astaxanthin much better. We can take a much lower dose and get the same blood levels and hopefully therefore tissue levels, to have the impact at a much more feasible dose. And so it is important to confirm that supplement has bioavailability. And in the case of astaxanthin, there's even differences within the astaxanthin supplements. And so when I started in the space in the late 90s, and then ultimately in the year 2000, our company brought out one of the first astaxanthin dietary supplements, which was extracted from microalgae grown on the Big Island of Hawaii. And then we spent many years looking at pharmaceutical applications of astaxanthin, did laboratory production of astaxanthin to make it highly pure and consistent, and then special formulations to make it even better absorbed. And a few years back, we did a study where we took one of the typical astaxanthin dietary supplements that's extracted from the algae, and then took our version, which is produced in the laboratory, that's highly pure and consistent and specially formulated. And we got a group of human volunteers that were just healthy individuals, and then gave them all 24 milligrams of the kind of off-the-shelf microalgal form of astaxanthin, and then measured their blood levels at multiple time points over 24 hours, and then sent those samples to the lab with our specially developed analytical methods to measure how much astaxanthin was in the blood at all of those time points. And then we sent them home for a week. And in the case of astaxanthin, it has about a 24-hour half-life, which means every 24 hours, about half of the amount of the astaxanthin in your body goes away, is kind of processed out. And so after a week, 7 half-lives, you think, from 100% to 50% to 25% to 12.5% to 6.25%, and keep going down by half, 7 times, you're down to basically non-detectable amounts of astaxanthin after a week of it washing out of your system. Then we brought the same group of people back to the clinic, and then gave them 24 milligrams of our astaxanthin, and did the exact same measurements over 24 hours. And then when we compared the amount of astaxanthin, it turns out that we had both 3 times the maximum concentration, and then also 3 times the total exposure when you add up all of the time points over 24 hours. And we had 3 times the amount that was delivered to the bloodstream. And so in that case, you had the same group of people dosed the same amount in terms of the label, 12 milligrams per capsule times 2 for each person, but you got 3 times more actually absorbed versus passing through you. And so that's the thing where, one may be priced, lower, but if you're not absorbing it as well, then it actually can be much less cost effective compared to, say, in our case, something that is highly bioavailable. So that was a really interesting study that we conducted a few years back.
I'm sold. But before we talk more about this, let's talk about some of the other longevity nutrient supplements, what have you, that have been proven to work. Let's talk about creatine, polyphenols. Where does astaxanthin rank amongst these? Do you think it's better, as effective? What's your stance?
I think it's different than those. I think creatine has a really important role, obviously, in muscle health and energy. Protein is, of course, important. You want to build muscles and maintain muscle mass as you age, which is really important because people can lose muscle mass, which is a big indication of aging. And by the way, there's actually studies with astaxanthin in older adults who suffer from sarcopenia, which is the deterioration of muscle over time. And with astaxanthin, we actually saw, or the researchers, this was not our study, but another study conducted by others, saw muscle size and strength improvements in those cases. So I think someone would want to have protein and creatine, but also astaxanthin to help maintain muscle mass and strength. If you look at polyphenols, there's a lot of great research. But for instance, in that NIH ITP program, there hasn't been anything there that has extended lifespan. Or you look at the NAD precursors, and of course, NAD is a really important molecule in your cellular energy production and other cellular functions. And there are precursors like NR and NMN that help to increase your NAD levels, and that's very important. NR was tested in the ITP program and did not show increased lifespan. That doesn't, negate its utility in terms of overall health and energy production, et cetera. But it didn't have the utility in terms of actual lifespan benefit in that very rigorous program. Urolithin A is another molecule that has been demonstrated to support mitochondrial function. While it is a different molecule and works differently than astaxanthin also gets to the mitochondria. And just like your question about, does it get to the brain? We've also tested that it not only gets to your cells, but gets to the mitochondria in your cells, which is a highly privileged location and hard to get to. And so it gets to your mitochondria and gets to the membranes of the mitochondria and helps to prevent the oxidative damage to the membranes of the mitochondria, to the DNA of the mitochondria, and helps to promote mitochondrial function and mitigate mitochondrial dysfunction, which is an issue with aging. And so in the case of urolithin A, it is really well known for supporting mitochondrial function, but astaxanthin also does it, through its own mechanism of how it works, because it's chemically, if you look at the structure, just a different molecule. But I think that urolithin A has, based on the research, a lot of interesting, science and results. It hasn't been proven yet to work in the ITP program, but I know that the investigators of the ITP program are excited about it and its potential utility as well. So I think that's one to watch for sure. But I think astaxanthin can complement, a lot of these other longevity agents or overall health agents that people think about. I think it should be kind of a foundational supplement. People think about multivitamins, protein, probiotics, omega-3s. For instance, omega-3s help to replenish the fatty acids in your cellular membranes, which comprise the actual integrity, the structure of your membranes, and then the function of your cells, which require on things happening, at the membrane level. With astaxanthin, it gets into those membranes. It actually perfectly spans the cellular membrane, which is a lipid bilayer, and prevents the oxidation of those lipids. So if you think about the omega-3s helping to replenish the lipids that form the structure of the membrane, and astaxanthin helps to prevent the oxidation of those lipids in the membrane, they actually really go hand in hand. And because otherwise, if those lipids become oxidized, or it's referred to as lipid peroxidation, that can trigger a cascade of events that causes inflammatory pathways to turn on, for example. And so I think they work well together. And so it's hard to rank, what's better, what's number one, what's number two, because they all have different benefits and utilities. But I do think that astaxanthin stands amongst all of those key foundational agents, and should be something that everyone thinks about in terms of their overall health and longevity regimen. It's not like a highly specialized thing that a niche group of people may look at. This is something that virtually everyone could benefit from, incorporating into their day-to-day regimen.
And you can't take too much of it, right?
Yeah, I mean, it's virtually not. I mean, it's we have done studies, like I mentioned, up to 96 milligrams. That was a 12-week study with no side effects that were reported of clinical significance. There have been tox studies in animals, in mice and rats and rabbits and dogs and non-human primates, where they look at, or we and others have looked at very high doses and very long durations. So if a human is consuming 12 or 24 or 48 or even 96 milligrams, the mice were consuming either hundreds of milligrams or even grams per kilogram of body weight. So you might have 500 or 1,000 milligrams, like say 1 gram for every kilogram of body weight. In our case, if a standard human is 70 or 80 kilograms, that could be 500 milligrams or 1 gram for every kilo of body weight. So that just to show that the scale of what was tested in the toxicity studies in animals. And of course, there is the absorption difference, and so they may not be exposed as much even at extremely high doses. But essentially, in the animals, you could feed them virtually as much as practically possible to feed, and there were not overt signs of toxicity. Just like with anything, even with water, a high enough level can be toxic. So there is the assumption that at some level it would be toxic. But in this case, there hasn't been a defined top end dose where it's like, oh, watch out, if you take 48 milligrams, then that's really the top end, because you start to experience side effects. There is, of course, the caveat that everyone is different and has their own health status and condition, and so certain people may have GI issues just based on their GI already being more sensitive, and so you may want to look for that. Or if you're not absorbing it fully, because it is a molecule that is best absorbed with fats in a meal. And so it's not saying that you need to go and get a fast food meal, but just some typical healthy fats in a meal will help to promote the absorption of the astaxanthin, which if you don't fully absorb it, some people will see some of it pass through into their stool. And so the comparison would be if you ate a bunch of beets and you see colored stool, that can also happen with astaxanthin if one consumes, in particular, a very high dose and maybe isn't absorbing it as well as they could if they took it on an empty stomach, for example. So with that said, again, it's been proven to be exceptionally safe. We've had it in our diet for millennia. It's been on the market in supplement form for 25 plus years. There have been studies in humans at high doses, in animals at very high doses, very long durations. And some of these studies follow the animals for years and have not found things of clinical significance to humans. If anything, it seems like it helps the overall health and longevity to have it on board that whole time.
All right, so let's bring it home. So what separates your company AX3 from other supplement companies that supply essentially the same thing in a similar way?
We're the only one that are doing the laboratory-based version. And so the purity and consistency with our process is different from the forms that are found in most other supplements, which are typically extracted from microalgae. And that microalgae can be grown in open ponds or in closed tubes. And so if you're in the open ponds, it's exposed to the air and the elements. And so you could have airplane vapor, you could have fog from the volcano nearby or whatever it may be, rodents, you're exposed, it's outside. If it's closed tubes, you limit the contamination risk, but ultimately you're still getting an extract of the algae that may be 5 or 10 or even slightly more percent astaxanthin. But you have a bunch of other stuff from the algae, which is not necessarily harmful. It's not the active astaxanthin component. And so in our case, we are producing it in the laboratory. So it's just the astaxanthin molecule itself, the exact same natural structure that you would find in the algae or in the salmon, but without any of the other stuff. And it's consistent every batch. And then we take that and formulate it in a way that the body can absorb more effectively, like we proved in that human clinical study. And on top of that, we were the ones that supplied this formulation of this laboratory-produced astaxanthin to the NIH program, which demonstrated the increase in the lifespan. So if someone wants to have the version that was actually tested in the NIH longevity program, that has kind of this very rigorous manufacturing around it, was proven to be 3 times more bioavailable, then that's really why someone would want to look at us. And so with that said, though, we are still believers and supporters of astaxanthin just in general. And so whether it's from the algae or from the lab or from krill oil, whatever it may be, I think if people can get more astaxanthin on board on a regular basis, that's a good thing. And in the future, we actually may offer additional forms beyond the laboratory form for those that say, well, that's great and all, but I would prefer a form from the algae, and so we may offer those as well, or potentially people that don't want to take it in a capsule form, want to take it in a drink or a gummy. Which, by the way, another thing that distinguishes it is the extracts from the algae are typically suspended in oil and encapsulated in soft gels. And so if you have trouble swallowing a capsule, you're basically out of luck unless you pierce the soft gel and squeeze the oil out into something. In our case, we have hard capsules that can twist open and have our astaxanthin formulation as a dry powder in the capsule. And one could actually dispense the powder into a bottle of water or a shake or anything else, and mix it up. And you'll actually see the water turn bright red, almost like Kool-Aid, but it'll taste like water, which is kind of strange to have this bright red water that doesn't taste or smell like anything. But if someone does have trouble swallowing capsules or wants to just mix it into another nutritional shake, for example, that's another thing that could be done with our formulation. So those are a few of the things that separate us.
Dave, this has been awesome. Anything else you'd like to add? Do you think the audience would appreciate related to this topic?
Yeah, I think just wanted to explain that astaxanthin people will see that it's known as an antioxidant. And so we talked a lot about the benefits in terms of longevity and health, but in terms of why it's different than other antioxidants, I think that that's an important aspect to understand, because some people may think that all antioxidants are the same. And so you may think of vitamin E or vitamin C, for example. And if you take the case, or beta carotene, vitamin E or beta carotene will get into your cellular membranes, but based on the chemical structure of those molecules, they are not equipped to actually span and anchor across the membrane and kind of lock into position and stabilize the membrane of the cell, which could be the outer membrane of the cell, or it could be the membrane around the nucleus, which houses your DNA, or the membrane around the mitochondria, which houses the power plants, the energy production in your cells. And so astaxanthin gets to all these locations, and what was shown in a study that we did with a collaborator at Harvard to actually not disturb the integrity of the membrane. So it kind of slots perfectly into that lipid bilayer membrane, stabilizes that membrane, and then on top of that, it can fight free radicals or reactive oxygen species, which can damage your lipids, your proteins, your DNA, and can also trigger an inflammatory response that, when you have chronic inflammation, damages your tissues over time and leads to kind of health deterioration and aging. Astaxanthin can actually fight those free radicals or those reactive oxygen species in those membranes, both inside the membrane and at the surfaces of the membrane, because of the way that it spans and anchors across the entire membrane. And based on the backbone of the astaxanthin molecule and the ring kind of head groups, it basically has these two ring groups and then this long backbone in the middle. That entire structure, the ring groups and the backbone, are perfectly designed to neutralize those free radicals, and that is different than other antioxidants, which may get into a membrane and fight some free radicals, but can also disrupt the membrane as well, based on not anchoring in well. Or in the case of vitamin C, it sits, outside of the membrane, and so it's not situated there to fight off the free radicals that can cause those lipids to oxidize, for example. So it's very different in terms of where it's located, how it locates, and how it fights the free radicals that can cause the oxidative stress, if not dealt with on an ongoing basis. And then on top of that, people may see that it's referred to as an anti-inflammatory. And that's because oxidative stress and inflammation are intertwined. And so in the case of most anti-inflammatories, your inflammatory pathways will be turned on, activated for some reason, whether it's in response to an infection or a wound, or, to diet and lifestyle factors that disrupt your system. Other anti-inflammatories will go in and work on something downstream. So the inflammatory process is turned on, something bad is happening, and is trying to plug a hole downstream. But it's not actually turning off, the activation of the pathway in the first place. Or you can have an anti-inflammatory that basically just shuts down your inflammatory response regardless of why it's turned on. And so the whole point of inflammation, your immune response, is how we've survived, as a species, and just how life in general survives in terms of fighting off infections, whether it's bacterial or viral, et cetera, or wounds, wound healing. All of this is your immune response. But when it's chronically turned on and your body is always in this stress and emergency state, and it's always trying to fight off the invaders that aren't even necessarily there in a chronic state of inflammation, this damages your tissue over time. And so with astaxanthin, because it works as this antioxidant, it actually prevents the activation of your inflammatory pathways in response to oxidative stress, which you don't want on a regular basis. So that's a good thing, to have your inflammatory response kind of no longer activated pathologically on a day-to-day basis. But it doesn't prevent the activation of your inflammatory response to infections or wounds and things like that. So it basically allows your inflammatory system, your immune response, to just function normally as it should. Fight off the infections, heal wounds, but don't attack your tissues on a day-to-day basis and deteriorate your cartilage or the lining of your blood vessels, or your neurons and the ability for your neurotransmitters to be produced and transmitted, et cetera. So that's something that distinguishes it from other anti-inflammatories in terms of working upstream, preventing the pathological activation of those inflammatory pathways, but not their normal function. So that's how it can be both safe and effective. And when you think about it, mitigating that oxidative stress in the membranes, preventing the pathological activation of those inflammatory pathways, and doing that in the cells throughout your body in all these key locations. That's how it can have all these great impacts. And that's why we believe in it so much.
Well, thank you so much for sharing all of your wisdom. I learned so much from this conversation. And if people want to get a special discount, they head to ax3.life, use the code Doug for 20% off. And I like that you do a subscription model. I'm normally not a fan of stuff like that. However, I like how you say this is part of a daily habit. Like, this is something that you encourage people to take on a regular basis. It's not a quick fix. It's an overall lifestyle habit. So I love that. But ax3.life, use the code Doug for 20% off. And Dave, thanks again for coming on the show.
Oh, it's my pleasure. Great speaking with you.
Disease is, not caused by, but is oxidative stress. It's biomolecules inside your cells losing electrons to toxins and getting oxidized. You need to eat the best foods you can and digest them as best you can. The important thing that I feel in a diet is to combine foods correctly, because when you don't food combine correctly, you have poor digestion. So if you're high on calcium, low on magnesium, oxidative stress inside that cell is going to directly impact the mitochondria.